These two pictures of dogs are on page 365 in the text. So if we were to say, what's the average dog size in this picture? What's the average dog size in this picture? And if we had the actual, excuse me, if we had the actual weight, which we do, when you flip the page to page 366, we're given how much each dog weighs. Here's a list of weights for these dogs. Here's the list of weights for these dogs. When we find the mean, we add them all up, divide by 4, add them all up, divide by however many there are, we get the mean. This has a mean of 65.25. This has a mean of 64. On average, these dogs weigh 64, 65 pounds. But these two sets of dogs are really different. These dogs are all medium-sized dogs. This picture has some medium-sized dogs, but also a big dog and a little dog. So while the average dog size of both pictures is the same, the collection of dogs is actually really different. When we're talking about how spread out our data is, one piece of information that can help us talk about that is the range. The range talks about how far is it from the smallest to the biggest. So for this first set of dogs, going from the smallest, 58, to the biggest, 73, it's 15 pounds range from smallest to biggest. Whereas this set of dogs has a range of 95. The biggest to smallest is much further apart. Now, as we've talked about with measures of central tendency, if you have an outlier, sometimes that can really throw it off, and sometimes it doesn't so much. If we're talking about range, having an outlier will really throw it off. Perhaps you recall talking about the mid-range. The mid-range, smallest to biggest, divide by 2. You're finding the average value between the smallest and the biggest. So the mid-range, which is halfway between the smallest and the biggest, is really thrown off if all of your data is here, but you have one that's way up here. That's going to throw off your mid-range. Well, your range is just how far apart your biggest to smallest is. Mid-range is what is that middle place? The range is how far apart are they. So to find the range, we subtract. There we go. There's our range. Find the range. Biggest minus smallest. Pretty easy. A piece of information that can tell us about how spread out things are that isn't quite as influenced by an outlier is standard deviation. Now, the bigger the standard deviation, the more spread out the data is. Standard deviation is talked about on page 367. In fact, on page 367, we've got this italicized part right here. Standard deviation essentially describes the average distance that each data value is away from the mean. On average, how far away are these dogs from that mean value? The mean, remember, like the mean? So, on average, how far away is each dog from the mean? Here, on average, they're not that far from the mean. Here, on average, they on average are pretty far from the mean. You might want to, on page 367, just highlight that or star it. Now, it'd be good to note that there's actually two different types of standard deviation. Remember when we were talking about gathering samples and population and things to do with statistics? Well, there's a sample standard deviation and a population standard deviation, and they're slightly different. What we are going to use, unless you hear otherwise, sample standard deviation. If you want to talk about the differences between those two things, let me know and I'll point you to some extra resources if you just really want to geek out on statistics. But since we're just kind of scooting across the surface of statistics, let's just stick with sample standard deviation. They're pretty close to the same. Additionally, I am not going to make you learn how to do sample standard deviation by hand. I think one of the videos you're watching, they actually do that, but I'm not going to make you memorize that. In fact, if you wanted to, you could go through your book and find it by hand. On pages, boy, it starts on page 367 and it goes all the way through 369. What I want from you is an understanding of what standard deviation is telling you, like, oh, a bigger standard deviation means that the data is more spread out. A smaller standard deviation means that your data is all more consistent. It's all pretty close together. And I'd also like you to be able to find standard deviation using technology. In our case, using a spreadsheet. We'll do that on another video. The last thing I'd like to mention. Okay. Page 372 talks about relative standard deviation and the coefficient of variation. Those are two terms for the same thing. The coefficient of variation and the relative standard deviation, same thing. Two terms. Now you can find that for a sample standard deviation or a population standard deviation, but remember, we're just sticking with the sample standard deviation. The coefficient of variation. This is a lot of words, but you can see them all on page 372. The coefficient of variation is just the standard deviation divided by the mean. We're not going to spend a lot of time talking about it, but I'd just like to tell you that those things exist and that they are also ways to measure how spread out data is.